Happy morning. In this video we are going to discuss about oblique impact. What is oblique impact? So oblique impact means smooth collision between two spheres. Its velocity is inclined with the line of impact, that is oblique impact. So in this video we are going to discuss about the oblique central impact. Central impact means the center of two masses lies in a same line, that is oblique central impact. So let's consider two bodies A and B with the mass m1 and m2. Its initial velocity is u1 and u2. Its inclination with line of impact. The direction of motion of two masses m1 and m2 is inclined with the line of impact. That inclination is alpha 1 and alpha 2. So this is the inclination, which is alpha 1 and alpha 2. So after collision, the velocity of the two masses is going to change, which is v1 and v2. Again, before impact, the velocity is inclined with line of impact. So obviously after impact, the velocity of the two masses is inclined with the line of impact. That inclination is theta 1 and theta 2. So now given velocity is inclined with the line of impact means the velocity should resolve into two components, which is horizontal and vertical component. So we are going to resolve the initial velocity of the two masses into two components, which is u1 cos alpha 1, u1 sin alpha 1, and u2 cos alpha 2, u2 sin alpha 2. Like that, the final velocity is also inclined with the line of impact. So we have to resolve that final velocity into two components, that is v1 cos alpha theta 1, v1 sin theta 1, v2 cos theta 2, sin v2 sin theta 2. So during collision, the vertical component is not going to affect. So the initial and final vertical component should be same because it is not affected by the collision. So only a horizontal component is affected by the collision. So in conservation of momentum, we are going to consider the horizontal component alone. So what is conservation of momentum? The total momentum of a body before impact is equal to the momentum of a two bodies after impact. So momentum means mass into velocity. The product of mass and velocity is called the momentum. So now consider the horizontal component alone. So the momentum of two bodies before impact comes like this: m1 u1 cos alpha 1 plus m2 u2 cos alpha 2. The momentum of two bodies after impact is m1 v1 cos theta 1 and m2 v2 cos theta 2. So this will be the conservation of momentum for the two masses, which is A and B. Then after this, we are going to consider the coefficient of restitution for the two masses, which undergoes the oblique direct impact. So we are going to get the relative velocity of separation, which is v2 and v1. So we have to consider the horizontal component alone. So it comes like this: v2 cos theta 2 minus v1 cos theta 1. Then relative velocity of approach is u1 cos alpha 1 and minus u2 cos alpha 2. So we know that coefficient of restitution is a ratio between the relative velocity of separation and relative velocity of approach. So we can write the coefficient of restitution like this. We got this: v2 cos theta 2 minus v1 cos theta 1 equal to e into u1 cos alpha 1 minus u2 cos alpha 2. So we got the coefficient of restitution. So now by using this conservation of momentum and coefficient of restitution, we can find the final velocity of two masses. So now we can solve the problem. A ball of mass 500 grams moving with a velocity of 1 meter per second impinges on a ball of mass 1 kilogram moving with a velocity of 0.7 meter per second At the time of impact, the velocity of a ball are parallel and inclined at 60 degree to the line joining the centers. Determine the velocities and direction of the balls after impact. Take E is equal to 0.6. So we have two masses, mass A and B, with M1 0.5 kg, M2 1 kg. The initial velocity U1 is 1 meter per second. The initial velocity of a mass 2 is 0.75 meter per second. So it's travel in a same line. The velocity is inclined with the line of impact. So the inclination of U1 and U2 is same, which is 60 degree. The coefficient of restitution is given in the question, which is 0.6. So we are going to find the final velocity of M1 and M2, then its inclination with respect to line of impact, which is theta 1 and theta 2. Now come to the solution. We know that in oblique impact, the vertical component is not going to affected by the collision. So the vertical component of initial velocity and final velocity is same, which is A1 sin alpha 1 is equal to V1 sin theta 1, and the vertical component of initial velocity and final velocity is equal for the second mass also. So U2 sin alpha 2 is equal to V2 sin theta 2. So we know the initial velocity and the inclination. So U1 and alpha 1, U2 alpha 2 is given in the question. So we can substitute that value. So by substituting that value, we can get the equation 1 and equation 2. Now we can move to the conservation of momentum. So we know the conservation of momentum. The momentum of a two masses before impact is equal to momentum after impact. So we are going to consider the horizontal component alone in the moment of conservation of momentum. So just substitute the value of mass and initial velocity over this equation. So we are going to get this. M1 is 0.5, U1 is 1, and alpha 1 is 60, and M2 is 0.75, U2 is 1 meter per second, and alpha 2 is 60. So by substituting this value, we got this equation. So 0.625 equal to 0.5 V1 cos theta 1 plus V2 cos theta 2. Make it as a equation 3, and we can move to the coefficient of restitution. So relative velocity of separation is equal to E into relative velocity of approach. So we know the initial velocity and its inclination with respect to line of impact. Just substitute that value, and the coefficient of restitution is also given in the question, which is 0.6. So by substituting this values over the equation, so we are going to get the another equation, which is V2 cos theta 2 minus V1 cos theta 1 equal to 0.075. Make it as a equation 4. Now by using this two equation, by solving equation 3 and 4, we can get find the V1 cos theta 1 is equal to 0.35. Make it as a equation 5, because we don't know the values for theta 1 and V1. So make it as another equation 5. So we have equation 1 and equation 5. So we are going to divide these two equations. So equation 1 is V1 sin theta 1 equal to 0.866. Equation 5 is V1 cos theta 1 equal to 0.36. By dividing this, so V1 remaining is sin theta 1 and cos theta 1. So sin by cos is tan, so it becomes tan theta 1 equal to the value of this two ratio is 2.405. So from here we can find the theta value. So theta 1 is equal to tan inverse of 2.405. So we can get the theta 1 value. Now substitute this theta 1 value in equation 5. we can get the final velocity of a first mass, which is 0.937 meter per second. So now we got the final velocity of a mass 1. So I can substitute this final velocity in equation 3 or 4. So we are going to substitute the final velocity, so v1 in the equation. So by substituting the value, v2 cos theta 2 equal to 0.075 plus 0.937 cos 67.42. So v2 cos theta 2 equal to 0.434. So make it as a equation 6 because we don't know the value of v2 and theta 2. So now we have a equation 2 over here, which is v2 sin theta 2 equal to 0.649. Now we have equation 6, v2 cos theta 2 equal to 0.434. Now we are going to divide this to equation 2 by equation 6. So v2 sin theta 2 equal to 0.649, v2 cos theta 2 equal to 0.434. So by dividing this, we are going to get the tan theta 2 equal to 1.495. So from here you can get the theta 2 value. So theta 2 equal to tan inverse of 1.495. So you can get the theta 2 value, which is 56.22. So now you can substitute this theta 2 over this equation 6. So v2 cos 56.22 equal to 0.434. So from this you can get the final velocity v2 equal to 0.78 meter per second. So now we got the final velocity of the two masses, which is 0.937 meter per second and 0.78 meter per second. Then the inclination between direction of motion of the two masses with respect to line of impact, which is theta 1 and theta 2. So we got the value of theta 1, which is 67.42, and theta 2 is 56.22. So this is what asked in the question. So the final velocity and its direction. So this is the actual procedure to solve the oblique impact. So we got the v1 and v2, theta 1 and theta 2. Thank you, students.